All right, so we talked a little bit about combining vectors graphically in class, and I want to cover um, combining vectors algebraically, that is mathematically, in this video. And this can be a little daunting because it brings us back to our geometry days and working with right triangles, but it's actually a little bit easier than combining them graphically, and it's what we're going to be using most often. So it's important to sort of get a handle on what's going on here. As we talked about in class, right, vectors, right, they have magnitude and direction. And when we combine them, right, combining vectors or adding vectors, when you combine them, you add them head to tail, right? So on a vector, right, the head is going to be the arrow, right, indicating what direction this object is continuing on in, and the tail is sort of this point at the end, right? So when you combine vectors or add them, you want to add the tail to the head or vice versa, right? And when we talked about combining this graphically, right, we talked about the importance of defining your coordinate plane, right? Letting people know, what direction is positive and what direction is negative. So I want to do that just generally for this video, right? So while we're working with this today, I'm going to go with this direction is positive. This one's also going to be positive, negative, negative, right? And this is the horizontal or x component, right, of motion, and this is the y component, right, vertical. And you can divide, as we talked about in class, you can divide any motion into a y component or an x component, but you need to define this coordinate plane before you start so that your audience knows, where is your positive direction and where is your negative direction in this two-dimensional plane. So here I have two vectors, right, that describe the motion of an object in 2 dimensions, right? Here's the vertical component of its motion, and here's the horizontal component, right? And I want to try to figure out what is the overall vector, right, of motion of this thing. What is its magnitude and what's its direction? So if we were to do that graphically, right, we combine head to tail, right? So I would put the tail, right, of this vector on the head of the other. I could do this vice versa. It's going to give me the same general result, right? I could put this one here and put its head to tail this way. I still get the same vector here, right? So the combination of these two, right, I'm going to want to complete them using the same head to tail methodology, right? So my sum vector is going to be starting, right, at the head of this one, right, and its own head is going to end at the tail of the other, right? So this is my, if this here is, we'll call it vector A, right, and this one's vector B, my red arrow is the combination of vector A plus B, right? The overall motion of the object, right, is actually down and to the left, right? So we talked a bit about, working this through graphically, so this should look familiar. And now I want to talk about the algebra of it, right? Say we were given magnitude for A, right, is 2 meters per second, right? And magnitude for B is 3 meters per second, right? We could actually find the magnitude for A plus B. Using right triangle geometry, which some of you are probably going to be like, oh no, right? So if we're given the two legs of the triangle, right, this one and this one, right, we can find the length of this hypotenuse, right, using the Pythagorean theorem, right? We could use the Pythagorean theorem. Or, right, if we were given, say, the angle here of this was, 30 degrees or something, right, we could use SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent, right? So say that we were given this angle, right? This angle of the trajectory, or, maybe we were given this one, right? 60, right? We could say that the inverse tangent, wait, hold on, that is wrong. I would like to use the, hold on, back it up. Right, we could use, let's go ahead and use the Pythagorean theorem, right? You could use the Pythagorean theorem, right, which states that the square of one leg plus the square of another, right, equals the square of the hypotenuse, right? You could use that to solve for this distance, right? And that would give you the magnitude of this vector, right? Nice and easy. If you wanted to find this angle, right, what the direction of this vector was, you could do the inverse tangent, right, of the opposite over adjacent angle, right? So the inverse tangent of 3 over 2, right, is going to equal that angle. We'll call it angle, right? So there are ways that you can figure out these angles algebraically, right? Say we were given this vector, right? Say we were given some direction, right? Here's our vector. And the question was, what are the vertical and horizontal parts of this vector, right? What's making it up? In a sense, what two vectors are combined to create this, right? And right, you can go ahead and draw a triangle here for these two things, right? And right, if you're given the magnitude of this vector, right, say this is an object that's traveling in this upward direction, we'll call this, 20 degrees to the horizontal, right, and it's traveling at 3 meters per second, right, you can solve for the y component of this motion, right, and the x component using SOHCAHTOA, right? So you're given that the angle is 20, so the sine of 20 degrees, right, equals opposite over hypotenuse, so it's going to equal the y component over 3, right? Similarly, right, the cosine of 20 degrees is going to equal the adjacent over hypotenuse, right? The adjacent is the x component over 3, right? So that's how algebraically we break down these vectors. We're going to do more practice of this in class, but I wanted you to get a taste of what we're doing. And if you haven't seen this triangle geometry stuff before, right, SOHCAHTOA and the Pythagorean theorem, you need to come talk to me, because this is what our next unit is going to be about, and if this is new to you, we need to go over it so that you can join us where we're at with vectors, and we can move on to projectile motion. All right, see you guys tomorrow.